Welcome to my channel. Today let's just talk about Leetcode problem 2641, cousins in binary tree 1. So my suggestion is that you should solve the cousins in binary tree 1 first before you are solving the cousins in binary tree 2. So for this problem we are given the root of a binary tree, so we're gonna replace the value of each node in the tree with the sum of all its cousins values. Yeah, let's just use an example. Yeah, so in this example, we have the knot 5 as this knot 5 has no cousins, so it's gonna be just use the total sum. It's gonna be 5 minus 5, so it's gonna be 0. So for this knot 4, it has no cousins. Yeah, so the values will be the total sum in this level. It's gonna be 13 minus the 4 itself and minus its brothers. It's gonna be 0. And similarly for 9, and for this one. So the total sum gonna be 18. So 18 minus 1 and minus its brother minus 10. So what left behind is the sum of the cousins. So the sum of the cousins is the total sum in this level minus the knot itself and its brothers. Yeah. So it is 18 minus 1 minus 10. So it's gonna be 7. And similarly for others, this one gonna be 7 because this one gonna be 18 minus 1 minus 10, it's going to be 7, and for the last one, it's going to be 18 minus 1 minus 10, it's going to be 7. Yeah. So now, if you understand it, so what kind of a method you're going to use to solve such kind of problem? Of course, we can use BFS, tree BFS with level order traversal. So we can calculate the total sum of each level. So for example, this is 5, and the second level going to be 13, and the third level going to be 18. Now, the second step is that we need to know what is my cousins. So for example, for this node 1, my cousin is 7, but how should I know that? And this is difficult to calculate, but we should know that it is easy to calculate the brothers. So for 1, I know the total sum, and I know my brothers is 10, so I can directly use 18 minus 1 and minus my brothers 10, so it's going to be 7. So this is easy to calculate. Yeah. And actually for this problem, when I solved it, I made a mistake and it took me a long time to debug, and then I found the bug and I solved the problem. So the trick is that it told us that the number of nodes is from 1 to 10 to the power 5, but the node's value is 10 to the power 4. So this means in between, inside, there are going to be duplicate values. So for example, it is not inside the example, but here, let me just check, maybe we can find an example. We didn't find such example, but we should know that inside the node, it can be the duplicate values. So for example, this is node 4, and this 9, maybe this 9 can become a node 4, because it has duplicate values. So this means for our dictionary, while we need to build our brothers dictionary, it means 4's brothers is 9, and 9 brothers is 4. Yeah, it's not the cousins library dictionary, it is just brothers dictionary. Yeah, so this means we cannot use the values itself. We have to use the reference. So for example, the knot 4's brother is not 9, and not 9's brother is not 4. But in our dictionary, we should prepare two values. So one value is node 4, and another value gonna be the node 4's value. It's gonna be 4, and this gonna be the value, and the k gonna be a node 4. So we're gonna prepare such kind of a dictionary, and then we're gonna use this dictionary to solve the problem. Yeah, and this node 4 with a circle, this means it is a reference. So a reference as k, and another one is reference. I'm sorry, this one gonna be its brothers. It's gonna be reference of 9. Yeah, let me just clean a little bit. So inside, it's going to be the reference of 9 with a value 9. So this is going to be what we're going to prepare. So for reference 4, it's going to have reference 9. It means node 9 and its value. We have to do that. If we don't do that, currently if this value for the left side, if it updated to 0, so what's going to be the right side? So it's going to be the total value of 13 minus 0, not 4, because we've already updated to 0, so the value gonna be 4 instead of 0. Yeah, so this is why we're gonna prepare two values for the k. So we're gonna put it inside a list, so it's gonna be a reference and values. Yeah. now let me just start coding for this problem. I'm gonna prepare a queue. It's gonna be the queue, and inside I gonna put a root. Yeah, because there will be at least one node inside of the description, as you can see from the constraints. Yeah. Now I'm gonna check the queue. So while queue for anything in range, because I want to check level by level. Let me prepare some dictionary. So the dictionary gonna be the browser's dictionary. Default dict. I'm gonna put a list inside. Now I want to prepare a level array and a total sum, and gonna be 0. And I want to prepare a result array. So the result array gonna store the total sum of its level. Yeah. Now let me just start checking. So I'm gonna pop out to the node. It's gonna be equal to q.pop left. If node.left, we need to put it inside node.left. So if node.right, we need to put it inside the queue node.right. Yeah. So currently I think up to now everything should be clear, and we need to update the total value. It's going to be plus equal to the node.value. This means the total in this level. Yeah, I think up to now it is okay. I'm not sure if I do I need to use the level array? Maybe not. Maybe I don't need to use the level array. I think that is enough. I think a dictionary and a result array is enough for me to solve the problem. Yeah. So after that, I want to put the total inside the result array. Up to now, I think everything should be okay, but we didn't update anything inside of the dictionary, and we need to update it. But before that, let me just give a random return a root. Let's check what is inside the result. I think you should be clear with what is inside the result. Yeah. As you can see, inside the result it's the total sum of its level. So it is 5, 13, and 18. It seems everything should be okay. Now we just need to update the dictionary. Yeah. So for the dictionary, we need to update from here. So if node.left and node.right, we need to update the dictionary. So dictionary with node.left would be equal to an array. So inside it's going to be the it's going to be an array. So inside it's going to be the node.right and node.right.value, and similarly with node.right should equal to node.left and node.left.value. I'm not sure if you understand what is the meaning of the dictionary. So the dictionary is just the browser's dictionary. So for this node 4, I have a k with node 4, and value gonna be this node 9, and its value gonna be 9. Yeah, so this is just the idea. Because it's difficult to find the currents, so why not we just directly find the brothers? Because for node 4, I only have one brothers. At most, I have one brothers, but I don't know how many columns. Maybe I have 100 columns. I don't need to code one by one. I just need to know if I do have brother. I need to know this is my brother. So this is why I'm gonna prepare a dictionary to store the values and the reference. Because if I only store the reference, the value gonna be changed if I change the value of this node. So that is why I also need to prepare a value inside of the dictionary, because this is gonna be constant. Yeah. And this is not yet finished. We have to start another BFS, and we have to do 2 BFS. I mean, 1 BFS is not enough. Similarly, let me just copy something. Yeah, let me just copy the BFS part from here. So I'm gonna start a queue, and this queue gonna be the queue, and inside I will put the root node, and while queue. Yeah, I want to check for anything inside range length of the queue, because I want to check level by level. But currently I have the result array, and I'm gonna prepare an index. It's gonna be 0, so it's gonna be the first value inside my result array. It means level 1. Now I can check the node, so the node gonna be equal to q.pop left. So this is similar like before. It's just a BFS level order traversal. First gonna be node 5, and then we're gonna update this node 5. So if a node inside the dictionary, so we're gonna update it like this. So node.value gonna equal to the total. So what is the total? It's gonna be the result I for this level, and minus the value itself, and minus the dictionary with this node with the value. So the value gonna be 1 because we prepared two places. The first is reference and the second gonna be the value. So we just need to check the value. Yeah, I'm not sure. Do I need to keep a node.write? I don't even need to keep a node.write, but let me just finish coding, and then I gonna just make it concise. I just optimize the code. But currently, let me use my previous idea. Else node.value gonna equal to result I minus node.value. Yeah. Now we're gonna check if node.left we want to put it inside. Yeah, I don't want to copy it. Let me just type it. Maybe this is even more faster. Yeah, so q needed to append node.write. Yeah, now let me just submit it to check if it works. Let me just run it. It didn't work. Yeah, it means there's something wrong with my program. Because I think I forget to update the index I, because for the next level I need to update the index I. Now I'm gonna update it, and let's check. Now it seems works. At least I passed 3 testing cases, and let me submit it before optimizing the code. Yeah, as you can see, it works, and I think the speed is okay because this is a time complexity of O(n). Even we used 2 BFS, but the time complexity is O(n). Now let's just optimize. Yeah, for the first time, I think maybe I need to use this value. Actually, I don't need to use it. For the k, it is node.left, but for the value, I don't need to use this node.write. You can see for my second BFS, I didn't use it. Yeah, so this means I don't need to do that. So for the dictionary, I just needed to put an integer inside, and for here, I just needed to delete node.write. I just needed to keep the value because I only need the value. I don't need the reference. Yeah. So from here, it's gonna be the D node, and we don't need even to check it if it is inside or not because, yeah, it is a default dict with integer. Now I think I optimized a little bit about the code. Let me just run it. As you can see, it works. Now let me check, and I think let me just submit it. Yeah, as you can see, it works. Maybe it improved the speed a little bit because we improved the memory. We don't need to store the value as reference. We just need to store the value. And k is the reference, and value is the brother's value because we just need to use this value. I think this is really important for us to solve the problem. I think that's all for it. Maybe you can also optimize the code by some other ways, but basically we need 2 BFS. So for the first BFS, we need to record the brothers and the total sum of each level. For the second step, we just need to check each of the node by using the level order traversal and update the node's value for each of the node. So this is the entire code. Thank you for watching. See you next time.